Momentum is a central concept in physics. The broadest form of Newton's second law is stated in terms of momentum. Momentum is conserved whenever the net external force on a system is zero. This makes momentum conservation a fundamental tool for analyzing collisions. Hey everyone, I'm back with another video. This time, we are using relativistic momentum as an example to talk about the theories which happen to be the best descriptors we have right now of the universe. Interestingly, when we consider the expression for relativistic momentum, we know that it's a good descriptor of the motion of objects moving at all speeds. To understand relativistic momentum better, let us consider the following. Let us recall. In classical mechanics, if we have a particle with mass m which travels with velocity u, then we understand that the product of the mass and velocity is the momentum. Momentum is directly proportional to velocity and mass, which means the greater the mass or velocity, the greater the momentum. In relativistic momentum, what will happen if we have a relativistic activity? Therefore, the motion now here belongs to relativity. So for a very high speed velocity, momentum is again relativistic, and it is defined as a product of relative mass multiplied by velocity. But consider that the relative mass is equal to this formula. Substituting the values, we come up with the relativistic momentum formula. Now, if the velocity is much lesser than the speed of light, take note that this will become 0. Thus, the square root of 1 is 1. Therefore, the result will go back to the classical momentum formula. However, if the velocity is fast enough that it approaches the speed of light, this will then be subtracted to another number, which will lead to getting a higher momentum than the classical momentum. Relativistic momentum is defined in such a way that the conservation momentum will hold in all inertial frames. Whenever the net external force in a system is 0, relativistic momentum is conserved. For according to Einstein, nothing can go faster than the speed of light. Let us test your learning. What is the momentum of an electron traveling at a speed of 0.985 c? The rest mass of electron is 9.11 times 10 to the negative 31 kilograms. Comment your answers below.